Hello class, this is CSE-5250, sections 2 and 60, week 11, spring 2026. Okay, so upon request, I have been asked to provide instructions on how to automate benchmarking for your benchmarking project. So here it is. This is based on using a batch file if you're on Windows, or using a shell script if you are on a Unix system. So I'm gonna first get started with the batch file instructions. So you're gonna need to write for yourself a .bat file. That's the file type, by the way. Just call it benchmark .bat or something like that. And okay, I'm gonna assume that you have a means of saving your runtime to a file, and your executable program is set up such that it must accept two command line arguments, that is the array size followed by the thread count. Oh, and when you run this script, it must be in the same location as your executable file. So I'm going to assume that you already have a means of writing those execution times to a file. You have some means of capturing that execution time. Just in case you don't, there is a way to do that using fstream and possibly string. So these are the two libraries that you would need, or at least these were the two libraries that I personally used to benchmark a different program, and that program was the Civil Veritasenes. Ignore the if write time to file part. That's just a conditional statement that toggles the program from writing to a file or just printing out the prime numbers. The Civil Veritasenes is just a program that it's an algorithm that is used to find prime numbers up to a specific search maximum. And you can do this by hand if you wanted to. In the past, I assigned students to run this as their benchmarking program, and I might do that again one day in the future. But anyway, if you want your program to write execution times to a file, first you're gonna need to save that execution time. So remember, before you ran the sorting algorithm, you would have to record the starting time, and then after you run the sorting algorithm, you have to record the stop time. You do that by calling the function high resolution clock now, but then you need to save the difference between those two times. So duration cast microseconds, stop time minus start time. Keep in mind I am using namespace standard chrono just to save on having to type out the whole thing. But if you are not using namespace standard chrono, keep in mind that you must preface this and this with standard chrono. So now we have our execution time saved in a variable, and for us to get the execution time in this case it's microseconds. In the slides I was showing milliseconds, so keep that in mind. Keep note of what time unit you are using. Anyway, we now have this variable that is storing our execution time. For us to print it out, we say execution time.count, and that's what we use to eventually write the execution time to a file. But before we get to that, all this code is just to put together the file name to write. That's just to put together the file name in which we are going to write our execution time. There's probably a much neater way to write this, but that's just how I wrote it, and I cannot be bothered to refactor the code right now. If it works, it works. I'll leave it to future me to refactor it later. Anyway, we have our file name. It is execution times search max, where search max would be analogous to your array size, and then thread count.txt. And then file, we're gonna define an fstream object named file. We are going to open the file, pass in the file name, and then we're gonna specify these. This is just to denote that we are. All that is just to denote that we are writing to a file and we want to append to the file. But note that I'm opening the file and then closing it again, just to make sure that that file exists. And then I open it again. Again, I am going to append to the file because I don't want to overwrite anything that was already there. I want to add on to it. So with that file open, I'm going to write execution time.count, and then I'm going to write a new line. And then I'm going to close the file. And that's it. That's more or less all the code you need to write your execution times to a file. And assuming your search max and thread count, or I guess array size and thread count, are passed in as command line arguments, and you have a means of writing down the execution time as well, that is all you need to not only get your execution time, but also write it to a file. And all of this code would have to be after all the other code needed to even run the program in the first place. So here's the same program as before, but I've made a few slight changes just to pretty up the output. If we are to modify this program such that it has this all of this writing code, write to a file code, it would probably have to be after to do number 4 here. So this would be to do number 5. Write the execution time to a file. So yeah, that's all you really need to write to a file. Okay, so here is the program again. Make sure you build your program, and when you do, make sure, if you are on a Windows system, make sure you go to Project, Properties, and go to C/C++, look for language. Make sure that this OpenMP support option is turned on. That way you are running this program multi-threaded. Because if not, you're going to be running it on single-threaded, and that's no good. Anyway, now that we have the program and we have built the executable, what I am going to do now is I am going to right-click the solution up here, open in File Explorer, and in this new window that I have opened up, I am going to look for the executable. It's going to be in a debug folder, and if your project is a 64-bit project, you're gonna need to look for an x64 folder, and it's in there that you're gonna find your debug folder. In my case, it was an x86, so that's 32-bit. So debug, and there's my executable right there. For me to run it, all I gotta do is type in PowerShell in the address bar, and I already wrote the command needed to run this thing, so I am just gonna type in, and it's set up so that I have to pass in an array size. Let's do a size 1000 array with let's do a size 10,000 array with 1 thread. And that took about 2.5 seconds. Because these are microseconds, that's 1/1,000,000th of a second. So divide this figure by 1,000,000, you get your time in seconds. I'm gonna do it again with 2 threads. And it completed in about 1.3 seconds. I'm gonna do it again with 4 threads, and it completed in less than 1 second. I'm gonna do it again with 8 threads, and it completed in a little over half a second. I'm gonna do it again with 16 threads, and I got less than half a second. So we went from 2.5 seconds to 0.43 seconds. I'm gonna keep going, and I'm gonna do it with 32 threads. Because my system here has an 8-core 16-thread CPU, that means I'm hitting the limit of what my computer is able to do. So, yeah, look at that. I did not get any improvement at all. If anything, I got slightly worse performance. Let's do it again just to be absolutely sure. You don't have to go this far, but I am, for completeness sake. And look at that, the execution time went up. Probably because all those threads are fighting for the CPU now. Okay, so how would we automate benchmarking so that we don't have to do the up arrow, press the up arrow key to retype the command over and over and over again? Well, again, we can either write, depending on what system you are on, a batch file or a shell file. So these are both scripts, and I'm going to show you the batch file first. The absolute minimum that you need, and I'm assuming you have a means of writing down the sorting times, and your executable program has array size and thread count passed in that order, and you must place this script in the same location as your executable. Within that batch file, so you're going to have to save a .bat file with this code in it, where you replace executable name with the name of your executable, and really that's it. At the absolute minimum, this is it, though you will need to copy this command repeatedly and then change the thread count and the array size accordingly. And that is exactly how I did it when I had to benchmark my programs, but of course there is yet an easier way we can do that, and I've also provided that here as well. So this is a triply nested for loop that repeatedly runs this, which repeatedly runs your program. So this triply nested for loop is going to have two more for loops in addition to your original for loop. The outermost for loop iterates through a list of array sizes. So we're doing size 1,000, 3,000, 10,000, 30,000. We're going to go up the powers of 10 up until we can't handle waiting that long. And if you can't handle waiting that long, I added powers of 10 multiplied by 3 just as intermediate values. You don't have to add these unless you want to, and if you can't get to 1 million. Because in the instructions I told you, hey, try to get to 1 million, but if you can't, just add intermediate values instead. The next for loop after that, and this is going to be within the first for loop, is it's going to step through a list of powers of 2, and those correspond to your thread counts, because we are increasing the thread count by doubling it each time. So 1, 2, 4, 8, 16. In the instructions, I have you going up to 16, but if your CPU can handle it, go as far as you can. Go as far as you can. I have it go up to 64, even though, statistically speaking, not many of you are going to have 64-thread CPUs. I know some of you do have Ryzen 9s and Intel Core i9s, and well, if you do, you are probably ahead of the curve, and are probably equipped to do even more strenuous benchmarking. But let's look at the rest of the code here. So the outer for loop iterates through array sizes, the middle for loop iterates through the thread counts, and the innermost for loop uses the current array size and thread count as command line arguments to run the command to run your program, where executable name is going to be the name of your executable. And basically this is no different from typing in the command needed to run your program once. It's just that we're doing it multiple times. Here it is running it 30 times because in statistics that is the number of times you need to do something to get something statistically significant. But again, the more the merrier. And that's it. Just one command is all that's, just one batch file with this code is needed to run your whole project. And you can just run this thing overnight. And when you wake up, you're gonna get a bunch of text files that has all your results. So really all the work you need to do at that point is to just grab all those numbers, punch them into, say, a spreadsheet, and get the averages, and then just punch those in to your lab report. That's it. Okay, but what if you're doing this on a Unix system? You would need, you would need the equivalent code on a Unix system. And I'll get to that, but I also have to tell you, how are you supposed to run this anyway? Well, through the magic of doing this beforehand, I have already written the batch file here. I am going to right-click this and click on Edit, even though you can already see the code in the preview pane over here. I'm going to edit this just so you can see what it looks like, and there you go. Okay, adjust these lists according to what your computer can handle. I have it set up doing 5 runs for each combination of thread count and array size, but you're probably going to want to do more than that. So, there are 2 ways you can do this. You can just double-click this .bat file and run it as though it were an executable, or my personal favorite, I am just going to type in cmd in the address bar. This is going to open up the command prompt, and then I am going to type in the name of the batch file. So that is benchmark.bat. And just like that, it's running the program, one run after another. I highly recommend you do nothing else on your computer as this is running. That way, your program's not competing with any other programs for resources. Got it? And at that point, it's just a waiting game. And again, I highly advise that you have a means of writing down these execution times, preferably to a file. But yeah, that's basically it. So how would you do this on a Unix machine? Well, we would have to convert this code into equivalent code for a shell script. And I've already went through the effort of doing that for you. This is the equivalent code. This would have to go in a .sh file. Also, not all systems can apparently handle this syntax here. If you do, replace it with this equivalent code that I have highlighted down here. Again, it's a triply nested for loop. The outer for loop iterates through the array sizes, the middle for loop iterates through the thread counts, and the inner for loop just repeatedly runs the program using that combination of array size and thread count. And again, your program must be set up to accept command line arguments in this specific order, and it must be writing the runtimes to a text file. And to run this, you're gonna have to write the command bash and then the name of your shell script. And I have already gone through the effort of doing that in here. So this is the shell script, the equivalent shell script of the batch script that I had earlier. So I'm just gonna close this because I don't want to save this here. So I'm just gonna discard all the changes. I had also went through the effort of copying the program onto my virtual machine for Ubuntu. I already had the sorting algorithm here. So if I just do /sort, it's gonna segfault because it didn't add in the arguments for it. So I'm gonna do it again, but I'm gonna do a size 10,000 array, and I'm gonna run it with 4 threads. Now I get an execution time of 208,000 microseconds. If I do it again with 1 thread, I should get a different time, and yes I do, it's about half a second. If I do this again with 6 threads, and I know that's the limit on my machine here, now it's running the program in 168,000 microseconds. So a little over, no. Yeah, so a fraction of a second that this program is running in. But again, I do not want to repeatedly press the up arrow key just to run the program again and again. Instead, I'm going to type bash, and the name of the shell file, the shell script, is benchmark.sh. I'm going to type that, and now it's not working because I did something wrong. Yeah, that means somewhere in the code here I wrote it wrong. Yes, I did. Yeah, it saved the wrong thing. So I'm just gonna replace it with /sort, and let's try that again. There we go. Now it's going through all the benchmarks. And again, you would want these benchmark times, you want these times to be written to a file. So it's going to be writing to the file repeatedly. So yeah, that's basically it. So I'm just going to press Control-C to stop this here, and let's step through some of the example times I got. I got sorting a size 1000 array with 8 threads, and it took 108,000 microseconds. With 16 threads, it took 159,000 microseconds. And with 32 threads, it took nearly 300,000 microseconds. And that's because it was already past the limit of what the VM is able to do, because I only assigned 6 CPU cores to this. But yeah, regardless of whether you are gonna be using Ubuntu or Windows, you now have a means of automating benchmarking itself. Okay. So this week is technically supposed to be the week where we are supposed to start looking at MPI. I will have the slides for that, but I won't have the video ad for that for a little bit. And that's because I want to make sure that you have enough time to finish benchmarking the OpenMP project itself. I will push back the due dates if I need to, just to make sure you have enough time to, well, do all this, okay? Alright, so that's going to be it for this video. If you have any questions, be sure to let me know. And I unfortunately don't have everything graded yet, and I plan to have that within the coming days. Okay? So that's going to be it. If there's anything missing with your submissions, I'll let you know about that. But yeah, that's everything you need to know to speed up benchmarking for your project. Okay? Alright.